This video presents a quick overview of the HTTP protocol, but the basics of HTTP that is sufficient to implement a simple web client or like a web server or a simple web browser, particularly programmatically. Keep in mind, internet is essentially a conduit for data, so it's basically a large network of networks. And in this network of networks, we have web servers, which are computers with files and resources that are being made available for access with users on the internet. Typically, these machines have names. So, for example, www will be the name of a World Wide Web host, but the names can be different. So it could be CECLNX01. Notice that here the name of the machine is www, and it's in the domain miamioh.edu. So this www is just a common name that's used by web servers, and these web servers typically have directories and files from which they serve data to all of the clients that are accessing them, may it be web browsers or smartphones. Keep in mind the host names are used to ease remembering the host names. Typically, only the IP addresses are used in the protocols, particularly in the TCP/IP layers. The Hypertext Transfer Protocol, or HTTP, is used by the web clients or the web browsers to talk or interact to the web servers that are on the internet. So given a URL, say www.miamioh.edu, so when you type this URL into a web browser, the web browser basically generates a series of lines. This is called a HTTP GET request because it has the word GET in it. So notice how in the URL, the resource that is requested is what you're doing, get that resource from the host www.miamioh.edu, which was specified in the URL there. There can be many HTTP headers, but typically these are the minimum that you will need, and that will be more than sufficient. Notice that each header is terminated by a \r/\n, 2 characters instead of 1. This request is then sent via a TCP/IP connection to the web server, and when the web server receives it, it looks at the resource that is being specified in the GET request, checks to see if the file is available. Let's assume the file is available in this case. So it pulls the file from disk, and then it counts the number of characters, basically figures out the file size. In this case, let's say it's 14 characters or 14 bytes. Then the web server forms the HTTP response, which is just a series of lines of strings. So it's just a bunch of strings where it says 200 OK as the first line, saying it was good. And then it provides a bunch of response headers as part of the response. And a blank line basically will separate the response header from the actual data that is included in the response. And this whole chunk is sent back to the client. Let's look at a quick demo of the raw HTTP request, and it's easy to see the raw data going back and forth via a telnet. The way to understand the HTTP protocol in a little bit more detail is to look at the raw lines of headers and responses being exchanged between a web browser or a web client and a web server. Here's the URL that I'm going to emulate as if I'm a web browser. So here the server is csnxmiamioh.edu, and the default HTTP port is port 80, and the resource I want to get is this file. Notice that I'm including the slash in the resource. So I'm going to use the GET protocol, and I want to talk HTTP 11, and I'm going to include the host name, which is cclnxmiamioh.edu, and these would be the headers that the browser would generate. And these are all the request headers, and then you terminate a request with a blank line, and then immediately the server responds. Since these are the response headers, notice that these are just plain strings. The first line is going to be 200 OK in a success response. You'll have a bunch of response headers, and the headers are terminated with blank line, and here is the raw data that's coming in. And you interpret this data based on the content type. Here in this case, it's plain text, and the content length is 33. This would be the way that small payloads are sent by the web server. Later on, we'll see chunked responses for large data being sent by the web server. And you can simply write a simple C++ program to process these strings, and it would work just fine, because here you're doing basic string processing. That's all HTTP is essentially string processing. All right, hope you enjoyed that demo. Let's continue where we left off. So here, the response from the server is basically sent back to the client. So the client gets these response, and the client has to process the response from the server. Typically, we'll check that the response is 200 OK to make sure that the response is valid so we can process the data. And then you can process the response headers, but typically, we will skip over the response headers until we hit a blank line. So typically we'll use a simple for loop to keep reading line by line from some input stream. Let's say this is the socket stream in which you're getting. As long as the header is not empty or just a blank \r, we will keep reading and discarding those headers so that we can get to the data. Note that we're skipping over the header so that we can get to the data and process it. And of course, the processing of the data will be different depending on what type of data is included in there. Typically, you'll use the content type header to tell you what type of data it is, whether it's text plain, whether it's image and such. So here's just a sample response. So for example, here's a response from HTTP. This is the response status code. These are all the response headers, and the order and the number of headers can vary. There'll always be this blank line separating the response header from the data. And then you will have data. In this case, the data happens to be HTML. So the content type is indicated as text HTML. So you know you're getting HTML data. Here it's important to know that HTTP and HTML are unrelated, even though they're often used in conjunction with each other. HTTP is the protocol, HTML is the markup that is used for displaying data in a nice format on web browsers. Keep in mind, HTTP by basically is a very simple protocol, right? So by default, HTTP is essentially stateless. That means two requests to a same web server, even from the same browser, are completely unrelated. So the web server has no way to actually relate these requests. And since we cannot relate it, this limits the ability for the server to manage what's called state, which is important for like logins, for managing shopping carts, etc. The state basically says who is logging, that it gives that relationship between successive requests from the same client. So HTTP cookies are used to solve this problem to give a state. So the server basically sets cookies in an HTTP response. So when the server generates a response, it'll use the set cookie header to set a cookie on the client's web browser. So the first time the cookie is set or every time the cookie is updated, the browser basically manages those cookies. Yeah, and you can see that set cookie header. So here is a cookie being set. The name of the cookie is counter and its value is 25. Just a simple example. So here the client stores the cookie. So the web browser will store this cookie inside it. And every time you make a request back to the same server, that means it has to go back to the same server or the host, then the cookie is sent in the request header via a cookie request header. So the server will use the set cookie, client will echo or send the cookie back with the cookie header. And the server can then use this cookie header it can use some information. Typically, they'll put some IDs and such in these cookies. And this information is used by the server to connect or establish that relationship between successive HTTP requests so it can manage state and provide some of the more complex and sophisticated functionalities like logins, managing shopping carts, and things like that. Now let's look at another useful and important way the web server might respond is chunked HTTP response. Servers can often send responses in small chunks, and this is done when the size of the data is not known or the data might be large. So rather than sending a big packet of data, the web server will break the data into small chunks and then send them to the web browser or the web client. Here, note that the request remains the same. So when you make a request, you do not know whether you're going to get a chunked response or a single block of response. So the way you can tell whether the response is being chunked or not, you will see this transfer encoding chunked response header. This is the response from the server. So server is telling you, I'm going to give you data in chunks. So when you get this transparent encoding chunk, you'll notice that the content length, which tells you what is the size, is not there, or typically may not be there. Sometimes it may be there, but typically it will not be there. So you can generate these, the way the chunks are generated is you will start with the size of the chunk. So note that here the chunk sizes are in hexadecimal, which can be generated in C++ by just using the stdhex modifier. And then you print the size of the chunk. Yes, there's a backslash or backslash n, so there is these unprintable characters on each line. And then you have the data associated with the chunk. Then you'll get another chunk. Here the chunk length is 39. No, this is not decimal. This is hexadecimal. And the data associated with it. And finally, you'll get the chunk with 0, the last chunk with 0 size, that indicates that all the chunks have been sent to you by the web server. So you can keep on getting chunks, and this is very common when you're streaming data, when you want to stream like movies or music or big data to a web browser or a web client. You can stream the data in small chunks, and then each chunk is processed by the web browser or web client to display the data that is associated with it. And this is called chunked HTTP response. And that's a very convenient way for the server to send data to the client. And of course, the content type header again informs the browser about the type of data being sent. You can see different content types like text plain, text HTML. If they're images, it could be image PNG, image JPEG, so on and so forth. So you'll have different content type headers. And based on this content type header, the browser interprets the data differently and displays it as images or HTML or just text, so on and so forth. Let's look up a simple example of coding up an HTTP server. This is just a boost example. Here's the content type where from a given some path on the server, some file path on the server, it pulls out the file extensions. And if the extension is HTML, PNG, it generates corresponding content type or MIME types in this method. By default, it just returns text plain. And then here is a stream to send chunked response to the back to the web client. Just a standard HTTP header. Here the transparent encoding is going to be chunked, and the content type is from the earlier helper method that we just saw. And then this method basically reads line by line from the data and writes the line back out with its size and the actual content as a single chunk. So it sends a series of chunks. Yeah. And then finally, it sends the 0 chunk to indicate all of the lines in the file have been streamed. And this is the kind of data that you'll get from this method. So it basically puts whatever is the content type, transparent encoding chunked, and then you will see all of the chunks coming out. Now let's put them all together. We just saw the serve client method in the previous slide. Here we just connect to a random port with 0. So it starts listening on a port. We accept a connection from a client. This is all pretty standard boilerplate. And then we serve the client by calling this helper method that we saw that's going to read the file and do some processing with it. In summary, keep in mind HTTP is a very simple multi-line protocol. It's a pretty dominant protocol on the internet, so it's important to be comfortable, particularly the inner workings of HTTP. It's good to know that. Keep in mind all of this HTTP is basically just simple string processing. People will wrap it up in complex layers, like you will use backend servers, whether it be in PHP, Django, and other frameworks, or the front end may be single page applications that is built in React.js. It doesn't matter. All of these are just data, are simple strings. And you can also almost think of it as coming from a text file, and you can use text files as input files for debugging and testing, and that's commonly how a lot of the HTTP is tested. Just basic, simple text files as input. Yeah. Of course, when you're working with projects and such, it might be a little bit more involved, so it's important to understand your starter code, have a mental model of what is already done or what the HTTP protocol is done. Of course, write some pseudocode whenever you're working with HTTP or any programs, write pseudocode in Commons. And of course, you can always use the most important tool, the debugger, to troubleshoot your web servers or web client when you're working with HTTP. Hope you found this presentation to be useful. Enjoy playing around on the internet with the HTTP protocol.